Hello everyone, welcome back. I'm Bud Churchward, WB7FHC, and this is the second in a series of videos about constructing the Nexus DR-X digital radio cross-packaged kit. Before we get into the construction, I'd like to just respond to a couple comments that we received on the first video that just went out last night. One of them comes from John, W1KLI, and he's talking about these little standoffs. They're magnets that my friend Agnes printed up on her 3D printer and sent to me. This is what John writes. He says, I really like the yellow 3D printed standoffs with the magnets. Kudos to your friend. Any chance you could share the plans so that we could print our own? Well, Agnes has come through for us. She's provided us with a link to a Thingiverse page where we can get the plans for those. I'll put that link in the description of this video. I've also added it to the comments on the first one. We received another comment, this one from Thuff, who is asking about the FeePi and would it be available for projects other than the Nexus. We could probably make that happen if that's something you're interested in. Why don't you just contact me via email at the address that you see below, and we'll make arrangements to help you out. So let's get started. We've got a kit to build. If you'd like your own Nexus DR-X kit, go to WB7FHC.com to find all the details. So here's the directions that comes with the kit. I call these a parts list in order of assembly. And the reason I've got the parts in this order and the order that I recommend you put the kit together in has to do with the height of the parts. We're going to start with the smallest parts first and work our way up to the taller ones. And that will become obvious as we go along. So most of these parts that you see right here are the electronic parts. So let's get our box of parts out here and let's see if we can locate those. Looks like this package here has the transistors in it, the resistors in it. We'll start with here. It also, of course, has the printed circuit board. I've got the soldering iron all hot and ready to go, and I've added fresh water to the sponge. Let's open up this bag and see what's inside of it. We can put that little card out of the way. Here's our printed circuit board. We've got some really tiny resistors here, a couple of capacitors. Here's some LEDs. Oh, and over here there's another batch of resistors. So this is most of the electronic parts. We'll start by putting these in first. Let me set these things off to the side so that we can bring in the instructions and see what goes first. You're going to notice that I'm using this pad right here. This is something that I bought, a little package of these at the Dollar Tree. And it's kind of a foam pad, and it makes it easy for me to work because I can put parts on my printed circuit board and turn it over and press it down, and they kind of sink into this foam, and it gives me a nice way to hold them tight to the PCB while I'm soldering them. I could be using the same magnetic stands that Agnes printed for me, but I'm going to be flipping this back and forth a lot, and that might not be as convenient. So this is a method that I've been using for years. And for this part of the project, I'll stick with this method. I think we'll come back to her stands here in a little bit when we start doing some of the other bigger parts on the board. So let's see. Get the instructions again. And it says here that we're going to put in three 470 ohm resistors. They go in R8, 9, and 12. And it says that it's a tiny body, and it's got the color code there. So that'll be easy to find. We've got the three of them right here. They are very tiny. When I set up this project, I did this on purpose. These other resistors are larger. They're going to go in this space over here. So R6, 9, and 12 are these little guys right here. So we'll put these resistors in to that spot. Just bend them over and stick them in the holes. One more. There we go. Now when I turn the board over and I push it down into the foam helps the resistors kind of sink into the foam and holds them up there. I'm just going to get these leads out of my way a little bit and grab some solder. I'm going to clean off my iron a little bit on the sponge, and we will, I think I'll turn it. I'm always a little bit shy about diving too far into soldering. Oh, got to turn my fan on. And I'll solder, usually I just solder one lead on each of the parts so that I can turn it over and be sure that I'm happy with the way they're laying. It's a lot easier to fix things if they're only soldered in one place. I'll do the other side of those leads. That looks good. I'll grab my clippers, and you want to be careful when you're cutting off the leads. You don't want them flying. I wear glasses, which helps protect my eyes, but especially if you have somebody watching. Sometimes when we do a project like this, spectators come along. People want to see exactly what it is you're doing. You don't want those leads flying through the air where they might catch somebody in the eye. So hold on to your leads with your fingers while you're clipping them off. Well, that looks good. Let's get our directions back out, and we'll check these off. Of course, we've got the printed circuit board here. There are the three those resistors. So these resistors that we just put in the board are called current limiting resistors. They go along with our LEDs. Each LED has a current limiting resistor. Let me show you in the schematic. We have three LEDs on the board. Let me find one of them here. Right here. This LED is connected to GPIO pin 24 on the Raspberry Pi. And an LED would be just like a short to ground. When GPIO 24 goes high, that's 5 volts. 5 volts running straight to the ground on our board. So we have to put in a resistor to limit the current. Otherwise, we end up burning out the LED. Well, the next thing on our directions are 9 3.3 thousand ohm resistors. Let's take a look at those. They're all together here in this one band. When I first started this project, we had 2 or 3 different values of resistors that we were going to use, but I discovered that I could get by replacing some of the 1,000 ohm resistors with the same 3.3 thousand ohm resistors that I was using on other parts of the circuit. This allows me to simplify the parts list for the kit because all of these resistors are exactly the same value. It makes it hard for you to get them in the wrong spot. So you'll see that there are 9 resistors listed here on the silk screen of our printed circuit board, and all 9 of these will go on in those places there. So let me get started. I'll put them in and we'll proceed. I'm kind of going to try to put the colors so that they all line up together here. Just makes it look nicer. Not that anybody's ever going to see it. There is no polarity to resistors. It doesn't matter which way you put them in. It's the same either direction. So don't worry about it. Some parts we do have to pay attention to which way they go, but resistors are not one of those parts. Let's take a look at what those resistors are doing. Here on the schematic, we have R1 and R2. These are connected to GPIO pins 23 and 12. GPIO pin 23 is the one that controls our push-to-talk on the right radio. And this pull-down resistor, it's connected to ground, makes sure the GPIO pin 23 stays low so that our transmitter doesn't come on when we don't want it to. R2 does the same thing for the left transmitter. We call these pull-down resistors. Over here, we have pull-up resistors. These are all connected to 3.3 volts, and they keep these GPIO pins high until we flip a switch and ground them. This is our piano switch. It's got 4 individual switches all in one package, and it'll fit into a typical 8-pin socket arrangement on your PC. Same as an IC, 8-pin IC. The switches could be turned on individually, and we can use them for multiple purposes in our Nexus DR-X. There are 2 more resistors, R10 and R11. These resistors run from the GPIO pin to the transistor, which is going to key our transmitter. It's similar to what's going on down here with our LEDs. We're limiting the current that goes in to the transistor. It means that just a small amount of current goes in to drive the transistor, which will turn on the push-to-talk in our circuit. Now, typically, this resistor here would be about 1,000 ohms, but I ran a little experiment to see if I could eliminate the need to have a third valued resistor and used the 3.3 thousand ohm resistors in the circuit here that I was using as pull-up and pull-down resistors. I found out that it worked perfectly well, and it means fewer different parts for our project. I've put 7 of the 9 resistors on for now. Let's flip it over and we will start soldering. Clean up my soldering iron a little bit and we'll go down the row here. I'm only doing one side of each resistor. It's kind of the standard way I do things. There. Take a look at that. Might bring the magnifying glass over. Take a look at what we have here. They look pretty good. I'll go ahead and clip that half off so they're out of the way. Again, I'm holding on as I take the pins off the leads. I got a trash bin under the bench that I'm putting those on. Okay. So we'll do the other side, and I'll get back to you right away. I'll put the last 2 resistors on the board, then we'll get the list out and check them off. These 2 guys right here are capacitors. You can think of capacitors as if they're little tiny shock absorbers. These capacitors are going to go with the transistors that we use in our 2 push-to-talk circuits. The Nexus DR-X allows us to run 2 radios at the same time. So we have 2 separate push-to-talk circuits. These guys go in between the radio side of the push-to-talk and our ground. And so if there's any kind of bump or spike along the way, these capacitors right here absorb it and keep things running smoothly. So let's put them on the board now. Like our resistors, there's no polarity to these, so they can go on the board either direction. So they'll go in here where it says C1. and C2. They'll go right there. Our transistors are going to go right next to them. We'll flip that over, press it down, and let's solder those in. Coming right along. We'll mark those guys off here. And the next two parts are our IC sockets. Yes, we're going to have to get into our parts bag. That's this guy right here. There's a lot of stuff in here. Let's take a look. I'll get the acrylic stands out. We'll be putting those in near the end. I'll just set them out of the way here. We also have in here a bag of hardware. That'll be part of the stand. Let's see. We need some sockets. IC sockets. That would be this guy right here and this guy right there. Just put these over here off to the side for now. They'll be out of the way. And let's take a look at these. So these right here are not going to actually hold any ICs. This would be their usual job in a printed circuit board. No, we're going to use these instead as jumpers. Jumpers that would be used to configure our RJ45 connector and the TRRS jack that's going to go on the underneath side of the board. You see this stuff right here? This is some handy little tape that's not too sticky. I actually got this inside of a box with some printed circuit boards that arrived from JLC PCB. That's where I get almost all of my printed circuit boards made. Anyway, this little tape is real handy when you're putting things together and you need to flip things around. I'll just go ahead and tape this socket right to the board like that. Kind of hold it down tight and tape it down. And I think I'd like to use Agnes's board here. Let's get that set up and take our FEPI out of the way. We're going to need to move these around a little bit. I'll get these two in here, and then we'll put these two. That hole's over here, like that, and over here. There, that holds that tight. Now our socket is in there. I think I'd like it a little tighter than that. Let's see if I can do that. Maybe what I'm going to do is get smart here. I'm going to solder a couple corners on this part first, and then we'll put it in Agnes's gizmo that is so handy. So let me get down here and solder this one. I'm actually pushing down on my circuit board in order to hold that tight against that socket. And I checked it there. I'm going to show you something when I pull the tape off. Okay, that'll hold it in place for now. I'll pull this tape off and I'll set it aside to be used again later. Typically, when you're putting an IC socket on a board, you will find a notch at one end. And on the printed circuit itself, the silk screen will have a gap or a notch in the silk screen, and you would normally line these up with each other. Because we're not putting ICs in these sockets, it really doesn't matter, but it's a habit. It's a habit that you should probably get used to. Now, because I'm going to use our little stand over here to do this soldering, I'm going to go ahead and tack the second one in as well, and I'll do a couple corners on it. Flip it over here on my pad, Then I'm going to solder one at this end. And I'll solder one at this end. That'll hold everything in place. And pull the tape off again. And now we're going to bring our soldering stand in here. And I'll put that in there. There. That'll hold it while I'm doing the soldering. Oh, thank you, Agnes. This is going to be so nice. Okay. Let's see. I'll go ahead and do the little guy first. And now we can do a 16-pin socket. Look how easy that is. With the thing being held so solid for me. I don't think I've ever had it this good. Oh, I gotta be careful not to melt the top of that 3D printed post. Oh, okay. Look at there. Get that out of the way. Get our list. And we can check these two off. Just like that. Next will be push buttons. Well, I don't know if you've spotted it or not in the video, but when I was soldering the smaller of the two IC sockets, I forgot one pin. I left it unsoldered, and I spotted it just a few minutes ago and took care of it. So it's always a good idea to keep checking your work. It's easy, especially when there's so many of them that you're doing quickly, that you can accidentally skip one. So that's all taken care of. So on our project, we have added a little tactile button. Here it is right here. It's a little tiny thing. Let me show you on the other camera. This little tiny button right here, this nice little push button, is something that we've added to the board that allows us to either shut down the Raspberry Pi or restart it with just a push of a button, and not have to actually bring up a menu. And sometimes people run their Raspberry Pis with no keyboards and no monitors and no mouse, and it's nice to be able to do a proper safe shutdown, even though you don't have a keyboard and mouse to do it from the screen. So the button itself goes in this spot right here, and at first glance it may look like it's square. It's not. It's a rectangle. So the button will only go in one of two ways, and both of them are right. So don't worry about that. So you just press it in. It'll kind of click into place. If I can get mine in. Like that. And it holds itself in place right there. And that's intentional so that the automated soldering systems can take care of it. So we'll put this back in on our little stand, and I think things may have slid a little bit. There we go. And now the challenge is to find it. There it is. I think I will be really careful with that one pin right there that is so close to the 3D printed stand that I'm going to solder the other three. I think I can do it carefully. There we go. Just like that. Now I didn't check that before I did all of the other pins, because you'll do it. When you see it, you'll know it's in. It's not going to even fall out if you turn it upside down. So we've got that in. Let's check that off and find out what's next. Oh, headphone jacks. Got a couple of those. Our FeePi sound card has two audio jacks on it. One for playback and one for record, or capture and play however you might think about it. So it's an input and an output. And we're going to do the same thing with our Nexus board. And we will then link these together with little jumper cables. And that's why we call it a cross patch. So we have stereo in and stereo out on the FeedPi, and then we'll match it up with the same jacks on the Nexus board. Over here, I'll show you. I'll find them here. These two guys right here. These are going to go on our board. They come right here on the front. They'll slip in kind of easily there. I'm going to take the tape again and put that down. Maybe I can do two of them at once. Depending on which jacks you get, some of them I found almost kind of snap in place. These are not the snappy kind, but so a little tape there, I'll hold them. I'm going to flip it over. There's actually 5 pins on these, and I'm going to solder just one of them on both of those guys. This is the ground pin. It's separated from the other 4, which are the left and right channels. And let's pull our tape, and I just want to make sure that everything's down flat and everything's exactly the way I like it. Let's grab Agnes's jig and we'll set our board up on here. I think one of my guys has drifted around. There we go. And we can quickly solder the other connections. Those look good. All right. Now that the headphone jacks are in, we'll put some LEDs in. We got a red one, a blue one, and a green one. They are push to talk, red for the right radio, blue for the left radio, and then we added a green one, which is actually clear when we look at it. That will be part of our reset boot button. So here we have our LEDs. Now, so far, the parts that we have been putting on the board are not polarized. It doesn't matter which way we put them in. When we come to putting in our LEDs, however, it does matter. We've got to get them in the right way. So you'll notice when you look at the LEDs that there's a difference in the length of the leads. Maybe you can see them there on the board. One is longer than the other. You're going to see that there's a square pad and a round pad. A little hard to tell, but one of the pads is square and one of the pads is round. And if the designer of your board has done it in a standard way, the square pad will take the long lead. That's the way I have designed this board. So you can be sure that if you put your parts on the square long lead in the square pad, it will be correct. So I'll just put that down and I will flip it over. On these I just solder. It doesn't matter which one you do first, but I only solder one. And that gives me a chance to see if I've got it lined up, and if it's straight, I can put my finger on the back of it here, remelt this solder, and I can feel it seat itself tight against the board. Double check it, and it's sitting there nice. I love these little square LEDs. I discovered them some time ago, and now they're my favorite ones. Okay, so the red LED for our right radio push to talk is now installed. Let's do the left radio. Okay. And again, I'm going to look for the square pad and put the long lead into the square pad. A little bit of tape. Flip it over, kind of press it down. I'll solder the one closest to me. And then I will pull the tape again. And like I did before, I put my finger on this part and I'm going to remelt that solder. And I can feel it kind of come together. I'll double check it. See, it's crooked. I don't like that. I could just maybe straighten it by bending it. Let me try one more time. Maybe have a better grip on it back there. Yeah, I felt it move. Oh yeah, much better. So that's how easy it is. Now, if you get ahead of yourself and you solder both sides of that part, you're going to find moving it around like I just did to be really difficult. So do yourself a favor and just do one. I have seen a lot of people build kits. We have build parties and we do them. And I see people just go solder, 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 and then they flip the board over and they go like, oh, that's crooked and this is crooked. And some of them will say, well, what the heck? It doesn't matter. It's going to work anyway. But I like to see things, see how they look. Now, we have a series of still photos. We have a series of still photos on the website that show you the parts as we go. And this LED right here, this green one, which looks clear, is not in those photos. Those photos are taken with an earlier version of the board. So if you're following photos along while you're doing the build, you're not going to see this LED in those build photos. But it's just sitting here. It's really close to the 16 pin header. Oh boy, I bent those guys. When I push down on that, I'll just solder one of them. Long one in the square pad. He's a little crooked. We'll get this situated. See, I feel it move, and now I feel it tight against there. Check it one more time. It looks good. We'll solder the round one. There we go. Now, let's clip those leads off. See, it didn't matter that I bent it. And we have now pull out the directions and mark those off. So now I'm going to install just two more parts and we're going to call it quits for today. These will be the transistors. The transistors are used for keying our transmitter. They're like a switch that we'll use to turn the transmitter on and off. So we've got two transistors. I'll put them right here. And I'll just do one at a time. The transistors are going to go in here right next to these capacitors. And if you look carefully at the silk screen, you'll see that there's a curved line next to the transistor there. And there's, when you look at your transistor, it has a flat side and a curved side, and you will put those together. Now, the leads on these transistors are really close together, and the holes on the printed circuit board are not. So what we're going to have to do is just separate these three leads just slightly, and you'll see that when you put them on your printed circuit board, we're going to kind of adjust the width and get them in there. That when they go in, the transistor, yeah, just for a minute there, I thought I had it backwards, but no, I don't. This flat side is here, the curved side is there, just the same as in the silk screen. They won't go down all the way because of the difference in the spacing on there, but that's okay. We'll just kind of make sure that it's straight, and then I'll give you a little bit of heads up. We're going to be putting another board in here where this rectangle is. So you don't want your transistor to lean over into that space there. So yeah, that's down there. It's going to hold itself fairly good right there by itself. I'll just kind of flip it over. I could use the jig for this, but it's only 3. I'm going to solder only one. I'm soldering the center one. And now I'm going to take one last look. I like to see things straight. That's just me. Has nothing to do with how the circuit works. It just has to do with what your board looks like when you're done. And people will be looking at this. You should be proud of it. And let's make it look good. Okay, that takes care of that guy. Now I'll do the same thing to the other guy. We'll probably do that one off camera. Okay, that pretty much winds it up for this video. We've got most all of the electronic parts installed on the board. Take a look at it over here on the bench camera. Just give you a little walk around here. All of these resistors we've talked about are pull-up resistors and pull-down resistors. We've got 2 resistors right here that are connected to the base of our transistor, and from there they go over to GPIO pins 12 and 23. Those are the pins that are going to key the transmitter, so that the other side of the transistor takes off and heads to the push-to-talk connection that goes to the radio. So we've got those on. Our capacitors are here. They're like the shock absorbers. We talked about those. We have our LEDs in place, and we have 3 current limiting resistors for the LEDs. When we get to the next video, we'll be installing the connectors that are going to go to our radios. Remember, we can have up to 2 radios connected to any of 4 different connectors, which makes it pretty handy. So hope you've enjoyed this video so far. Come on back, there'll be more, and we'll eventually actually get this thing on the air. How much fun will that be? And hey, don't forget to subscribe, like, and share.